When upgrading a residential electrical panel from a 3-wire system where the neutral and grounding conductors are bonded together to a 4-wire system where the neutral and grounding conductors are separated, circuits installed with service entrance, or C, cable containing 2 hot conductors and 1 bare conductor are affected. The bare conductor in SE cable is intended to serve as both the grounding and neutral conductor in a 3-wire system. In a 3-wire panel configuration, the bare conductor of the SE cable is connected to the neutral bus bar, which is also bonded to the grounding bus bar. This arrangement effectively combines the neutral and grounding functions within that single conductor. However, when transitioning to a 4-wire panel, a critical change is required. In a 4-wire panel, the neutral and grounding conductors must be kept separate. The bare conductor from the SE cable must now be connected exclusively to the grounding bus bar. A separate neutral conductor must be run and connected to the neutral bus bar. Failure to properly separate the neutral and grounding conductors in a 4-wire panel can introduce a significant electrical safety hazard. If a fault occurs on the neutral conductor in a miswired system, current can potentially flow through the grounding conductor. This unintended current flow through the grounding conductor can cause it to overheat, leading to a risk of fire. This is because the grounding conductor is not designed to carry the same level of current as a neutral conductor under normal operating conditions. The purpose of the grounding conductor is to provide a low impedance path for fault current to return to the source, facilitating the rapid tripping of a circuit breaker or fuse to clear the fault. The neutral conductor, on the other hand, is designed to carry the unbalanced current in a circuit under normal operating conditions. When the neutral and grounding conductors are improperly connected, the grounding conductor can become energized, posing a shock hazard to anyone who comes into contact with grounded metal objects. In addition to the fire and shock hazards, improper wiring can also interfere with the proper operation of sensitive electronic equipment. Electronic devices rely on a clean, stable ground reference to function correctly. When the grounding system is compromised, it can introduce noise and interference into the electrical system, which can disrupt the operation of electronic devices. To ensure safety and proper operation, it is essential to adhere to the National Electrical Code, or NEC, requirements for separating neutral and grounding conductors in a 4-wire panel. The NEC provides detailed guidelines for grounding and bonding electrical systems, which must be followed to ensure electrical safety. Firstly, identify all circuits using SE cable with a bare conductor. Secondly, verify the panel is configured as a 4-wire system with separate neutral and grounding buses. Thirdly, disconnect the bare conductor from the neutral bus bar. Fourthly, ensure the bare conductor is securely connected to the grounding bus bar. Fifthly, run a separate insulated neutral conductor to the neutral bus bar. Sixthly, inspect all connections to ensure they are tight and properly made. Seventhly, test the continuity of the grounding system to ensure it is properly connected. Eighthly, test the voltage between neutral and ground to verify they are properly separated. Ninthly, document all changes made to the electrical system. Tenthly, consult with a qualified electrician if you have any questions or concerns. For example, NEC Section 250.24. V addresses grounding requirements for separately derived systems, which is relevant when dealing with subpanels or generators. NEC Section 250.32 covers grounding requirements for outbuildings supplied by feeders or branch circuits. NEC Table 250.122 provides guidance on sizing equipment grounding conductors. NEC Section 310.15 outlines ampacity tables for conductors, which are crucial for selecting the correct size conductors for the load. NEC Section 408.41 covers the requirements for switchboard and panel board overcurrent protection. NEC Article 547 provides specific requirements for agricultural buildings, which often have unique grounding and bonding needs. NEC Article 680 addresses the requirements for swimming pools, fountains, and similar installations which have stringent grounding requirements due to the presence of water. NEC Article 690 covers solar photovoltaic systems, which have specific grounding and bonding requirements to ensure safety and proper operation. Remember that electrical work can be dangerous, and it is essential to take all necessary precautions to protect yourself from electrical shock. If you are not comfortable working with electricity, it is best to hire a qualified electrician to do the work. A qualified electrician has the knowledge, skills, and experience to perform electrical work safely and correctly. They can also ensure that your electrical system complies with all applicable codes and regulations. When hiring an electrician, be sure to check their credentials and references. Ask them about their experience with similar projects and make sure they are licensed and insured. It is also a good idea to get a written estimate before any work begins. The estimate should include a detailed description of the work to be performed, as well as the cost of materials and labor. By taking these precautions, you can help ensure that your electrical work is done safely and correctly. Always to energize the circuit before working on it. Use insulated tools and wear appropriate personal protective equipment, such as safety glasses and gloves. Work in a well-lit area and avoid distractions. If you are unsure about anything, consult with a qualified electrician. In addition to these general safety tips, there are also some specific precautions that you should take when working with SE cable. SE cable is often used to supply power to appliances such as ranges, dryers, and air conditioners. It is important to select the correct size SE cable for the load. If the cable is too small, it can overheat and cause a fire. SE cable must be properly supported and protected from physical damage. It should not be installed in areas where it is likely to be exposed to moisture or chemicals. SE cable connections must be made properly to ensure a good electrical connection. Loose connections can cause arcing, which can lead to a fire. Before working on any electrical circuit, always verify that the circuit is de-energized using a voltage tester. Never assume that a circuit is de-energized just because the breaker is turned off. A voltage tester is a simple, inexpensive tool that can save your life. When using a voltage tester, be sure to follow the manufacturer's instructions carefully. Touch the tester to the conductors to verify that there is no voltage present. If the tester indicates that voltage is present, do not work on the circuit. Call a qualified electrician to investigate the problem. In addition to voltage testers, there are other tools that can help you work safely with electricity. These include insulated screwdrivers, pliers, and wire strippers. These tools are designed to protect you from electrical shock. When using these tools, be sure to follow the manufacturer's instructions carefully. Always wear safety glasses when working with electricity. Safety glasses will protect your eyes from flying debris. Also, wear gloves to protect your hands from electrical shock and burns. When working on a ladder, be sure to use a ladder that is rated for electrical work. The ladder should be made of fiberglass or wood, which are non-conductive materials. Also, be sure to position the ladder on a stable surface. Do not overreach when working on a ladder. Move the ladder as needed to stay within reach of your work area. If you are working in a wet or damp environment, be sure to take extra precautions to protect yourself from electrical shock. Wear rubber boots and gloves, and avoid touching any metal objects. Also, be sure to use a ground fault circuit interrupter, or GFCI, to protect yourself from electrical shock. A GFCI is a device that can detect ground faults and quickly shut off the power to the circuit. GFCIs are required in many areas, such as bathrooms, kitchens, and outdoor outlets. If you are not sure whether a GFCI is required, consult with a qualified electrician. Following these safety precautions can help you avoid electrical shock and injury. Remember, electricity is dangerous, and it is important to take all necessary precautions to protect yourself. If you are not comfortable working with electricity, it is best to hire a qualified electrician to do the work.